Hello and welcome to another episode of the Space Update. Coming up on today's show, Inspiration 4 takes flight, Perseverance sampling success, and is nuclear-powered propulsion the way forward for space? Let's find out. So first up, launch updates on Thursday the 16th of September at 12:02 AM UTC. We had Inspiration 4 launching from Pad 39A at Kennedy Space Center. Then we had a bunch of launches from China that are penciled in from this weekend onwards, but no confirmation on definite time and date on those yet, but just keep an eye on our Twitter feed for that and we'll just give you the latest updates. So Inspiration 4, as you know, that one launched last night. For those who are not aware, Inspiration 4 is a private mission to orbit purchased by Isaacman, the billionaire founder of Shift4 Payments. He'll be joined on flight by Haley, Sian Proctor and Chris Zambrowski. The team will ride to orbit on SpaceX's Crew Dragon capsule, which is scheduled to launch atop of Falcon 9 from Kennedy Space Center's Pad 39A. The Crew Dragon in question is a vehicle named Resilience, which also flew on SpaceX's Crew 1 mission to the International Space Station for NASA. But there will be no meet-up with the orbiting lab on Inspiration 4. Resilience will circle Earth solo for 3 days, then come back and parachute-aided splashdown in the Atlantic Ocean, as was seen with previous splashdowns with SpaceX. An inspiring private mission by SpaceX. Will we see more of these flights? Possibly, but they do not come cheap, so this may be the first of a few planned private missions with SpaceX, but again, we'll see where that goes. Moving on from Earth orbit onto Mars, NASA's Perseverance rover has recovered from some temporary drilling issues in the past week. Perseverance collected and drilled out a core of Martian rock, dubbed Rochette, and sealed the sample in its designated titanium tube. The success came just after 4 days after the car-sized rover collected its first ever Martian sample, which was also cored from Rochette. Perseverance landed inside the Red Planet's 28-mile-wide Jezero crater on February the 18th. The 6-wheeled robot's tasks are hunting for signs of ancient Mars life and collecting catches of dozens of samples, which will be brought to Earth by a joint NASA-European Space Agency campaign a decade or so from now. A tweet from NASA Perseverance, my first 2 rock samples are likely volcanic with hints of salts and may hold bubbles of ancient water. So if you like to support what we do, head over to patreon.com/total space, gain access to our exclusive Discord community, chat with special guests on the show and so much more. And you can follow us over on Twitter and find us over on totalspace.net. That's our website. Enjoy the show. Now, for a number of years, we've relied on more or less the same propulsion methods, but is all that about to change? The Defence Innovation Unit last week issued a call for bids for small nuclear-powered engines for space missions beyond Earth orbit. The US Department of Defense wants lightweight, portable and long-duration power sources that can support propulsion and on-station power for sensing and communications on small and medium-sized spacecraft. The Defence Innovation Unit said electric and solar-based propulsion systems are not suitable for missions beyond Earth orbit and are likely too bulky for them to use in modern commercial spacecraft. Advanced propulsion technology that enables high delta V and electrical power to payloads while maintaining fuel efficiency is required to enable the new Department of Defense missions set in space. Submissions are due on the 23rd of September and the Department of Innovation's unit would award contracts within 60 to 90 days. These contracts will be for laboratory-based prototype testing. Bidders have to show credible manufacturing and licensing paths towards prototype development within these 3 to 5 years and follow-on path to flight-based testing. NASA and the Defense of Advanced Research projects are currently funding the development of fission-based propulsion and power such as nuclear thermal technology. The DIU for short says it's not duplicating any existing programs but is seeking to support current government projects with mature commercial technologies that can provide power and propulsion in the near term. Making sure these systems are safe is another concern for the DIU, as they want systems that can minimise radiation to the ground personnel during spacecraft integration and radiation exposure on the surrounding components. I hope you enjoyed this week's episode. Click here for the Humans in Space episodes, or click here for Rocket Lab. Catch you next week.